All right, today we're going to take a look at section 6.5, indirect proof and inequalities of one triangle. All right, so what is an indirect proof? That's what we'll start off with. And right here we have our definition, which is another way of proving a statement starting with a false conclusion. So let's say we wanted to say that since it's the winter time, it's cold outside. Well, in an indirect proof, we're not going to start off and say it's cold outside. We're going to start with a false conclusion saying, oh, it's hot outside. And then what we end up doing is we start talking about all of the different ways that it's actually cold. Like, because it's not hot. Like, I have to wear a heavy jacket because it's so cold, or my fingers are freezing. Um, Frost is coming out of my mouth, right? So we talk about all the different ways that contradict what we're actually trying to prove. So we have three steps right here in writing an indirect proof. Step one says, let's identify the statement you want to prove. We'll assume temporarily that this statement is false by assuming that the opposite is true, just like the example I gave you. Step two, reason logically until you reach a contradiction. So I started listing all these things. I'm like, oh, that's not a true statement, right? Every reason I'm giving contradicts my my temporary assumption. So then at step three, we were like, well, we point out that the desired conclusion must be true because the contradiction proves the temporary assumption is false. So let's take a look at an example right here. And I seem to have a square ABCD listed on the screen. And at the bottom, I put, all right, this is what I'm trying to prove. A quadrilateral is a square. Okay, so I don't know that a quadrilateral is a square, but I'm going to try to prove that. I did put a little markings there, but I guess in actuality, we could probably get rid of these markings. And I'll do that right now. Okay, so I took off those markings that were there. They weren't necessary because we're trying to prove that a quadrilateral is a square. And so let's remember, so step one, we're going to identify the statement and we're going to come up with a false assumption. So I put right here, well, a quadrilateral is not a square. Something as simple as that, right? Something that is a temporary statement that assumes that the opposite is true. Okay, so let's go to step two. We're going to reason logically. And I'm going to list all the things that I know right here. Okay, we know that all sides are congruent. Okay, so that makes up a square. We have opposite sides are parallel. We have four right angles. So those are all things that we can come up with as far as what a square is, right? So how about now to kind of mention to, well, go ahead and put those markings there because I didn't want you to think, all right, in the beginning this was automatically a square. So, but these are all characteristics of a square that you should be aware of. And from here, okay, all of these show that this is a square. And so we're going to point out now that the assumption that quadrilateral ABCD is not a square is false. Therefore, this quadrilateral ABCD is a square. So this being a square, you got to know what the characteristics are. We'll talk about more characteristics of quadrilaterals, different quadrilaterals coming next semester, but that is what we are taking a look at right now. Okay, or I guess things that you should, characteristics of squares that you should be familiar with just based off of uh, you know, math and knowing what a square is and looks like. Let's take a look at Theorem 6.9. We have the triangle longer side theorem. It says if one side of a triangle is longer than the other side, then the angle opposite the longer side is larger than the angle opposite the shorter side. Bottom line here is this, and I've mentioned it a lot of times already. The longer the side, the bigger the angle is opposite of that side. Okay, so therefore, look at this side right here. This has a side length of 8. BC has a side length of 5. Well, based off of that, I know that angle C is larger than angle A. Okay, just that simple. Longer the side, longer the angle, or bigger the opposite angle to that. We can't necessarily say anything about angle B because we don't know how long angle B is. But looking at this, I know that that's an obtuse. It looks like it's the longest side here. So if we were to say which one is the longest angle, or sorry, which one is the biggest angle, it would probably be angle B. But since they didn't give us that information, we're just going to say, hey, angle C is greater than angle A. The next theorem right here is the triangle larger angle theorem. And so going the opposite is, look, I look at my angles. I see that angle A is 50, angle C is 30. Well, angle A is the larger angle, therefore BC right here has to be the longest side with comparing that to AB. All right. Now, which one is the biggest side? I could definitely say that this is AC. The reason why I could say that is I know how big angle B is. Angle B is going to be 110 degrees, or actually 100 degrees. That's the biggest angle. AC has to be the biggest side. But that's because we have enough information to be able to justify that here. We couldn't make that kind of justification on the other problem, on the previous theorem, other than by saying, oh, by the looks of it, one of the sides is longer. And unless we took a ruler and measured it out, you wouldn't be able to do so. The next theorem is Theorem 6.11, the triangle inequality theorem. It says this, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So two sides of the triangle must be greater than the third side. You have to do this. The key to this problem and the triangle inequality theorem is you really do need to implement this 3 times. Check it 3 times. Because look, we have 3 different sides. So take AB plus BC. Is that greater than AC? Is AC plus BC right here greater than AB? And also check, is AB plus AC greater than BC? So make sure you use the theorem 3 times. That's the big thing that I put right here. And if the sum of the two sides is not greater than the third, the sides do not make up a triangle. The reason why I say check it 3 times is because sometimes you check it the first time it works out. But then there might be another 2 numbers that you put together and it doesn't. Therefore, if by not checking it 3 different times, you may not get the correct answer. It may only be true 1 or 2 times, but not all 3. All right. Also, here's the deal. Think about this. If I were to have a triangle right here, all 3 sides are good to go. They all equal each other. That means 2 sides are greater than the third. But what happens here is this. Let's say I have a triangle, these are my three sides. We'll say my two middle fingers is one side, and we've got the two other sides right here. Take a look. If the theorem doesn't hold true where these two sides is not greater than the length of this bottom of our base, what ends up happening is that the triangles can't close because the legs are too long. And that's why this theorem is necessary, or you need to understand that. Right here, all the sides, two sides are greater than the third on all of them. But something like this, it's not. So therefore, it can't close. I could try bending it, but then it's not a triangle because a triangle consists of three sides. All right, let's take a look at a few problems here. Let's start off. Right here, we're trying to write the first step in an indirect proof of the statement. The first one, not all students in a given class can be above average. Remember, our job is to start off by temporarily assuming, right, that this statement is false by assuming the opposite is true. So we always want to start the problem or the statement by saying temporarily assume. Okay, well, it starts off not all students in the given class can be above average. Well, the opposite of that would be saying all students in a given class can be above average. And that would be great. I'd love that if that was the case. All right. So that would be how we would write at least start our indirect proof. But then afterwards, what we would do is talk about all the things about class grades. We have 5 students who failed the test, or talk about all these different things to contradict this statement. Take a look at number 2. It says the number. It says no number equals another number divided by 0. So once again, we start off, we'll say temporarily assume, and then we could say that there are numbers A and B such that what? We can go ahead and say right here, think about how could we justify or talk about this statement. No number equals another number divided by 0. So they're saying like no number, we could say A all right, is equal, so no number equals another number divided by 0. So how about we could say A is equal to this another number divided by 0. Pretty much what we're trying to say. So such that A and B such that A is equal to B over 0. And this right here would be my statement. That would be the assume that a number A and B such that A is equal to B over 0. And that is the contradiction. Let's take a look at number 4. Number 2 is probably not the best problem, but once again, it kind of talks about how we will temporarily assume or assume temporarily the opposite of the given statement. Now let's take a look at number 4. It says determine which two statements contradict each other and explain your reasoning. We have A is triangle LMN is equilateral. B is LM is not congruent to MN. And angle L is congruent or equal to angle N. Well, if I have a triangle right here, and this is LMN, they're saying LM is not equal to MN. Well, I'd say these two contradict each other because if it's equilateral, shouldn't all the sides be the same? So right here, we can go ahead and say that sides should be congruent if triangle is, let's put it right here, if triangle is equilateral. Let's take a look at number 5. We have A is triangle ABC is a right triangle. Triangle A or angle A is acute. Angle C is obtuse. All right. Well, hopefully remember in our characteristics of a right triangle, one of the angles have to be 90. That means the other two angles are going to equal 90. You can't have an angle that is greater than 90 and have it be a right triangle. Therefore, A and C right here are contradictory. And we can go ahead and say that, once again, a right triangle cannot have an angle greater than 90 degrees. Or let's say it cannot have another angle greater than 90 degrees. It's just not possible. All right, let's take a look at next up. List the angles of the given triangle from smallest to largest. So I'm looking right here. I see that this happens to be the smallest side opposite angle C. So that would come first. That's the smallest side, smallest angle. Next up right here, I look at, this is the small side opposite of angle A. And then finally, that makes B the largest angle because it's opposite the largest side. Next up, let's take a look at 7. We got our different sides and angles here. Let's start off. Looks like 7 is the smallest side, therefore making angle D the smallest angle. All right, so D is the smallest angle. Then let's go ahead and take a look at the next smallest side, which is 15. That is opposite of angle E. And then finally, angle F, that's opposite of side ED, which is 18. Okay, so number 8, you can take a look at that, hopefully put it all together now. Smallest side opposite angle H. The next smallest side right here is 14, opposite of angle J. And then we have right here 16, opposite G. Make sure you read the question. Sometimes they may ask you to list it from largest to smallest. This time it's smallest to largest. So it really depends on the problem and how it is written. All right, let's take a look at number 9. Is it possible to construct a triangle with the given side lengths? If not, explain why. Remember, you have to have two sides must be greater than the third. Okay, the sum of two sides must be greater than the third. Well, how about right here? If I add up these two sides, 3 plus 17, is that greater? Or sorry, 3 plus 12, is that greater than 17? No, that's false. Okay, because 15 is not greater than 17. False. So this right here is no. My reasoning, I gave it to you mathematically this time. Let's take a look at number 10. 5 plus 21 is greater than 16. 5 plus 16, is that greater than 21? It's not. It's equal, right? 5 plus 16 is not greater than 21. This, once again, it is false. So that's a no. We take a look at 11. 8 plus 5 greater than 7. 8 plus 7 greater than 5. 5 plus 7, that's 12, that's greater than 8. So this one would be yes. Right? All sides work. Number 10, 10 plus 3, that's greater than 11. 10 plus 11, that's 21, that's greater than 3. And 3 plus 11, which is 14, that's greater than 10. So all sides work out right here. Let's take a look at number 13. Last problem. A triangle has two sides with lengths 5 inches and 13 inches. All right, so this is a very good problem. Very good. So make sure you know how to do this. We're trying to find all the different possible lengths of the third side. It's pretty easy to do, okay? Now, first off, make sure that the units of measure are the same. That's how they can kind of trick you in this question. So now that I know that the unit of measures are the same, let's go ahead and we'll add the two numbers together and get 18. And let's go ahead and take 13 minus 5, and then that'll get us the lower side that the triangle could be, and that right there will be 8. So what I'm figuring out here is this. This third side, and now we'll go ahead and put x. It must be right here less than 18. But it also must be greater than 8. So 8.1, 8.2, 9, 10, 11, 12, 13, 14, 15, 16, 17, all the way up to 17.9, that could be the length of the third side to make this true. Because remember, two sides must add up to be greater than the third. So if I take like 8 plus, and pick a number in here, like 8 plus 10, right there, it's going to make sure right here it works out because it's going to be greater than 13, right? It has to be greater than 13. So sorry, let's try this again. We pick a number like 5 plus 9, that's 14. So that's greater than the third side, which is 13 right here. 5 plus 17, that right there is going to be 22. That's greater than 13 inches. So all these numbers in between here would be your answer for this problem. So take the two numbers, add them up, and subtract them. Don't get negative numbers, then you know you're doing something wrong. Okay? And there you have it. You can find the different numbers that make up the third side. And there you go, section 6.5.